Hey everyone. I think we have 2 more minutes before we start, but maybe we can make use of that time. I'm Martin, and I'm going to do a little workshop about Avalanche. And kind of to adjust the workshop a little bit to the audience, maybe can you give me a hand sign if you are have written a line of code in your life, so I kind of can see that. Oh, good. Oh wow, nice. So technical audience today, very good. Yeah, so we're going to chat in a little bit about Avalanche. Who here is generally familiar with Avalanche, has heard of it? Okay, a few. Who has heard the term subnet before? Okay, good. So we'll cover that definitely today, and yeah, a little bit of the concept of virtual machines and how we can get the most out of the EVM. I think I'm just going to wait 2 more minutes so the actual time starts. Okay, nice, sweet. Cool, yeah, so thanks everyone for coming. My name is Martin, I'm a developer relations engineer for Avalanche. I was based in New York City for the past year, but just moved back to beautiful Italy. I live in Trento now, so only 2 hours north from here. I'm very happy to be back, honestly. So can't wait for the ski season to begin. Today I'm going to talk about Avalanche, and we have a, I want to get I want to talk about Avalanche, and I also want to talk about blockchain performance. So, right, blockchain have many different properties, right? But we're just going to look at performance today, so not at decentralization, all this kind of stuff, but just at performance. And when we think about blockchain performance, I want everyone to think about these 2 metrics, right? We have time to finality and throughput. And many people mix these up, right? Like if you had TPS, 1,000 TPS or something, you think a transaction takes 1,000 still of a second. That's actually not true. So kind of to illustrate these 2 metrics and how they relate to each other, or better, how they not relate to each other, how they're completely independent, I like to use this picture of a highway, right? Let's think of a highway, and each transaction is a car. And our blockchain is this highway and has 2 properties. One is throughput, right? So throughput is kind of like the lanes of a highway. The more lines a highway has, the more cars can travel through it, right? So obviously what we are aspiring when we're building a blockchain is a very, very wide highway, right? That can cater to a lot of cars. But we also have the second property, it's called time to finality. Think of it as a time it takes for you to come from wherever you're starting to where you want to go. And a good highway, if you build a good highway, it doesn't take a detour. So let's say I want to go from Milan to beautiful Trento, my hometown. I don't want to do a detour through Paris, right? Obviously, we could do that, but it would be very, very inefficient. So what we're aspiring for is a wide highway, which takes a direct route, so I get a short time to finality, right? I want to take the direct route 2 hours to Trento. I don't want to do 8 hours or 15 hours through Paris. So these are kind of the 2 metrics of blockchain systems. Just for the performance, as I said, there's a lot more security, decentralization, and all this. But we're going to look at these today. And we're going to look at especially throughput. And when we think of Avalanche, we build Avalanche consensus, right? So we have a time to finality from below a second, 0.5 seconds. That is very, very fast. If you think of Bitcoin, right, that's 60 minutes. You submit a transaction to Bitcoin. The time it takes to be final, so it's irreversible. You can be sure that this happened. You can, when you buy a coffee, the coffee maker will give you your coffee. This takes 60 minutes. That's very long, and for many applications, not really suitable. In Ethereum, we are a little bit better, right? We have a highway that is more direct. It only takes 15 minutes until finality, but we still only have a few lanes, right? The throughput is just not there, and that's where all these layer 2s and everything arises, right? We're trying to find a way to build a wider highway to accommodate more transactions. So if you look at Avalanche, we have a very, very short highway. It's very direct, below a second, and we are there where we want to go. So it takes below a second from in your wallet, you click submit transaction until you get the confirmation, and it's irreversible. And you can see also we have a pretty wide highway, right? This is not the widest highway out there. There are other approaches, zero knowledge, a lot of other approaches which actually build further, even wider highways. But as I will show you in a little bit, this highway is actually sufficiently wide for what we're doing. Because when we built Avalanche, we figured, okay, we want to accommodate a lot of people. We want to move a lot of transactions on-chain that are currently happening in traditional centralized systems. So we will need a very, very wide highway at some point. And then we figured, okay, there is just no way that any company, any organization can build a highway as wide to accommodate everyone on the planet, right? So what we came up with is a concept called subnets. And the idea is that we're moving away from a single blockchain with a single validator set to a network where we have multiple blockchains with different validator sets, right? It's a very, very simple concept. If you think about all scaling solutions, it's incredibly simple, right? So what does that mean? When we look at subnets and Avalanche, you can see each of these red dots here is a validator, right? So we have the primary network. That means all the validators are validating the Avalanche chains you may already know, the C chain, the P chain, the X chain, right? So this is the primary network. But now we can take a subset, right? And that's where subnet comes from, a subset of the validators, like the ones on the left here. And they are all going to agree to validate additional blockchains, right? So only them, not all of them, but only them are going to validate additional blockchains. And so may other validator subsets. And these subnets, they might overlap. So you can see these few validators up there. They are validating subnet 1, subnet 2, the validators up there, subnet 3. So we have changing kind of collection sets of validators that are validating these chains. So why do we do this, right? If you look at the concept we just talked about, we see a very, very nice effect, right? We see all these subnets, they're all running chains. It's not a single chain system, we have multiple chains. And we can say that because these chains are completely independent from each other, a transaction on one chain has nothing to do with a transaction on another chain, we get this massive combined throughput of the overall system here, right? So if we think of highways, let's think of, we are building a pretty good highway. It's very direct, it's pretty wide. But instead of just building one highway, we're building multiple highways in parallel, right? And this enables massive combined throughput. And since there is no real limit on how many highways we build or how many blockchains we launch, we get very, very high scalability, very, very large numbers of throughput. Yeah? Does that make sense? Okay, I see some people nodding. Beautiful. Cool. So we talked about throughput now. Throughput is good, but actually through the system we get another benefit, and that's customizability, and that's what I want to talk about today. So first of all, the first feature we get is independence. So we all know this, right? It's a bull market on Ethereum. There's an NFT drop happening. The entire economy goes down because everyone is minting this NFT. Gas prices go to the moon. It's really, really hard, right? When we have independent blockchains, these blockchains don't affect each other. Let's say, there's you're building a blockchain application for an institutional client, right? You want to have this independent from the gas spikes, from the congestion on another chain, because you're not related to the NFT drop, right? You can't explain your client at a bank that the blockchain is now congested and the transactions currently cost $200 because there's an NFT drop, right? They don't care about it. So we get really independent chains and independent, the usage of the chains is completely independent. But also we get customizability. So let's say, we have a highway, but some use cases just require different setups, right? It's really, really hard to build a highway where you have one lane where boats can travel, or one lane where a train can travel. But it's pretty straightforward if we get to a point where these chains are independent, right? So now we can adapt each of these subnets to unique requirements. And we're going to see multiple ways how to do that in a little bit. So why should we use subnets? First of all, we can have our own gas token on the subnet. So we are independent of the Ethereum prices or whatever is there. We have a combined higher throughput, but we can also do things like strict access control. We will see in a little bit. And we can customize the EVM and even create completely new specialized VMs. So one may ask now, okay, how do I build my own blockchain? And I'm just going to showcase how quick and easy that actually is. So we built a product. It's pretty new. It's called Eckardt, right? So I can connect my wallet There we go. Whoop. Okay. So, and now I can click here and click Create Subnet. I'm going to call it Martin's DevNet. We have our admin address. Let me just check that that's my address. Very good. And I'm going to click some stuff here that we will explore in a little bit. And now I click Submit DevNet, right? So what's happening now in the background is that Eckardt spins up my entirely, my own blockchain. So I have complete control over the validator set. We can look later in ways to decentralize that. We had an incredibly pessimistic front-end dev who put a 5-minute countdown there. It's already done, so the blockchain is already here. And we can already connect. Let's do it. So as you can see here, I can just add the blockchain to my wallet, right? And whoop. So give it 1 sec. Okay, my product manager already warned me that every time you want to show it, it's gonna take a little longer, but we're not gonna be impressed by that. All right. So what we see here is we have our own blockchain, right? We just deployed it. And now we can look into ways to customize this. Because now, when we're on a chain like Ethereum or any other chain, we always have a compromise between all network participants, right? So we need to, everything, gas fees, the pre-compiles, everything we have on these chains is always a compromise between all network participants. Since we're now on our own chain, we can actually, customize it a lot better. So if we look at the different layers of a blockchain, at the base layer we have the consensus, then we have the execution environment, and then we have smart contracts. These are the regular layers, right? They might be varying from other systems. If you look at Aptos as we have a different consensus, they have an execution layer, and then they have another smart contract language on top of it. So in Avalanche, as we just saw, we have a shared layer, a shared consensus layer, and now we have multiple EVMs that all have their smart contract language Solidity that are running in parallel, right? And now we can think of, okay, like how can we tweak this, right? Like why, since they're independent, why can't we just go and change small things about this? And there are 3 different ways we're gonna explore. The first one, super straightforward, right? Let's just say the gas price, the gas token, the gas limit. Maybe my app that I'm building is just not economical on a chain like Ethereum because my transaction would cost $150, right? Doesn't make sense to a lot of people. Not many people would pay the gas for that. So what we can just do on our own chain is we can change these parameters in a way that it becomes economical. We can also do very simple things, like introducing, permission and everything. We're going to talk about that in a minute. The other way is we can also modify this EVM that's already there, very simply, right? We just add something. So we built on top of years of research a very active Ethereum community, and we're just going to extend it. We're also going to see that in a minute. And the last one is, let's say we already have a pretty mature product, right? Like we have millions of users. Our dApp alone has like pretty high throughput. So maybe that is a point where we want to move from using the EVM and move towards a very specialized virtual machine, because we can't just take these inefficiencies, like these 40% inefficiencies of the EVM. It's just too expensive if we look at it, so it might be worth to do something. So if you heard of DYDX, that's a good case where they built their own virtual machine because the EVM was just too inefficient. Right? So VM configuration, right? Very straightforward. 2 things we can do is we can restrict, for example, who can transact on these chains. So this is big for, like especially things like KYC. If we want to enable only like, a permitted set of business partner they want to interoperate on chain, but they don't want to, they need to ensure for compliance, for regulatory reasons, that they're only interoperating with like certain things. So we see this with a lot of US banks. But also we can say, okay, this is not mutually exclusive, so we can do both, but we can also restrict who can, maybe we don't want to restrict who can interact with the chain, but we do want to restrict who can deploy contracts, right? If we're afraid that someone's gonna deploy Tornado Cash on our own chain, maybe we want to make sure that this is. So the idea here is pretty straightforward. We still have our highway, but we just put some access control on top of it, right? And we completely can decentralize it, right? We can do this on the fly. We can also delegate this to a DAO. But the simple way here, since we are not on a one-chain-fits-all system, is that we can do all these things. Yeah. Okay. Let's see if my blockchain has recovered. All right. So. Yeah, so we see here Martin's DevNet. I don't think I can zoom in the wallet, but you can see here this is my blockchain. I can just send some tokens to my own address so you can see it's actually real. 1,000 tokens, send now, transaction pending, boom. This is the finality I just talked about, right? Like below a second, as you could see, and my balance went down. So what we just talked about is I promised you a no-code approach here with the configuration, and you can do this all in Ava Cloud. So let's just say, we have an allow list of people, and we just want to transact with a very small subset of our business partners here on chain. What I can just do is, just gotta do enable testnet mode, I guess. Okay. So what I can do here is I can add addresses that are whitelisted to be able to transact on the network. I can also add addresses to deploy contracts. And I can do a lot of other things, like on the fly, without a network upgrade, change the reward structures, the fee structures, all this, right? So this is kind of the basic idea of this very low entry level, like very simple to do, launch your own blockchain that we can do with Ava Cloud, right? So the next step now is, okay, we are getting to a point where we are happy, we have our own chain, we have configured it in a way, but there are just some things that are not economical or just too risky to do in Solidity. So this is where we start modifying the EVM. We're not building an entirely new virtual machine, we're just modifying an existing virtual machine, right? And one incredibly efficient way to do this is precompiles. Maybe some of you are familiar with precompiles. They come from the Ethereum system. The very basic idea is to wrap an implementation in Golang in a Solidity interface, right? Let's look at what that actually means. So you can see here, this is a Solidity code, right? We see on top in line 5, we see that we are defining this interface for a hash function. I took SHA-256, actually a bad example because that already exists as a precompile, but we could take anything. Let's say you guys require some intense mathematical calculations for your DeFi protocol, you need like some zero-knowledge proof library or whatever, right? You can define it as an interface with with multiple functions, it doesn't matter. And now, as you can see in line 8, right? So we're defining a function, and very important to note, nowhere on the slide you see the implementation of SHA-256, right? We're just defining an interface. And then in our contract on line 12, right, we are loading this Solidity interface with a fixed address. You can see already the address looks weird, right? Like it starts with 03, a lot of zeros and 1. It's a reserved address space for these precompiles. And what we're doing now is we are calling this Solidity interface, but there's nowhere the actual implementation written in Solidity. It's at a very different place. Let me just change my screen to the actual editor. I think that's better visible. So if we look at it, where is now this implementation, right? And we're actually implementing it in Golang. So we're implementing it on the VM level. the beautiful thing is we can just import existing Go libraries. There's a very rich ecosystem. And that's all what we're going to do here is we're going to implement the function in Go, right? Actually, most of this code is already generated. So the only line I really wrote was this one here, where I call the Go library, right? Very, very straightforward, can be overwhelming in the first 2 minutes, but if you look a little bit into it, it should be pretty straightforward. So let's look at what this actually enables us, right? So one thing is, if you look at the optimization here, Go is incredibly more performant than Solidity. Solidity is a great first step at a EVM language, but you know, as you can see, many smart contracts are already moving to assembly or something, right? Like the readability gets really obscured and everything. So Solidity is not perfect. It's easy to launch a product. It's easy to make readable code, but if you have a very high performant DeFi app, you can't afford this. You need more performant code, otherwise the gas goes through the roof. Another very important feature of being able to work directly with Go libraries is that you have a very high level of security. You can use libraries that are out there that are published by, you know, like big research institutes and audited over and over again. We see so many hacks of teams that are re-implementing some cryptography in Solidity, which is just outright dangerous, right? So you can just reuse all these libraries. You can get it pretty easy because it's already implemented. You saw it was just one line of code. And then also you can increase interoperability. So we see this a lot in the ZK space. You know, it's pretty easy now, if there's a Go library for it, that you can verify ZK proofs, right? Because you don't have to re-implement anything in Solidity, you don't have to reinvent the wheel, and you can pretty straightforward just hand this down kind of to the Go level. Yeah. So does that make sense so far? See some nodding people, that's good. So now we talked a lot about the EVM, but the next step is that you're saying, okay, you know, everything so far was pretty easy. Configuration, 5 minutes. Precompiles, also pretty straightforward. A couple of weeks, you're up and running. But let's now say you're at one point in your product cycle where you become as relevant as a major DeFi protocol, Uniswap, you know, that kind of level. So you might want to look at alternatives to the EVM, right? And our stack here at Avalanche enables us. We are multi-chain system, but we are also VM agnostic, right? So we could see that we have a WASM VM similar to Cosmos SDK, where we have smart contracts written not in Solidity anymore, but in Rust. We have a team right now building, it's called Movement. They're building a virtual machine where they allow us to write smart contracts and move, you know, like similar to Aptos and Sui. And then the next part is actually where we join this application and this execution layer. So we don't have a general purpose VM anymore where everyone can submit their smart contracts, but we have the application logic written in the VM itself. And that's called Hyper SDK, right? And just for you to kind of see like, okay, why should I build the application and execution logic, right? There are some benchmarks here from Hyper SDK. It's all done in a local environment. All nodes are running on the same laptop, so take it with a grain of salt. We see 100,000 TPS right here. Let's say now in a distributed system, everything, we take 50% off that. It's only 50,000 TPS anymore. The EVM right now on Avalanche has like 2,500, so that's still a massive 20x lift. And to demonstrate like how this highway would look on the right, you can see it just so. It's a lot of lanes. It won't be enough to cater the entire humanity, but it's already, if you're like pretty good and like if you have a lot of throughput and you want to have that all on one chain, this is a way to go. So if you want to learn more about Avalanche, we have Avalanche Academy. It's completely free. What we just talked about is pretty much, so we covered a little bit of Avalanche fundamentals here, the virtual machines, the scaling, a little bit of subnet architecture. You will play more around with Evercloud, what I did in the background. And then if you want to learn about precompiles, we have a course there, Customizing the EVM. This one is definitely geared at developers. The first ones are non-technical, so you don't have to write a single line of code. So definitely recommend checking that out. The domain is academy.avax.network. And also you can learn more. Tomorrow we have one keynote of Luigi who is our head of DevRel and DeFi. And then tomorrow evening at 5, we also have John Nahas, our Vice President Business Development, on a panel here. So another opportunities to, not from the technical side, but learn a little bit more about different projects that are building on Avalanche. And yeah, thank you very much for your attention. If you have any questions, feel free to reach out, or I think we have maybe a few minutes now. Thank you. Does anyone have a question? Oh yeah, I see hands coming up. Let's see. Okay, I think you need a mic, otherwise you won't be on the recording. Thank you. You're welcome.
So first of all, I wasn't informed about what you guys were doing, and I think it's amazing, and it's
Thanks.
Incredibly important for this whole industry. You know, this is incredible. I'll read something more about it, but I have two questions.
Sure.
So first of all, once you've created your own subnet, do you choose your own validators? And secondly, or are they automatically assigned? And the second question is, I saw, maybe we didn't go too much into details about how you can customize your own subnet, but as far as I know about what I've saw, you can give some administrator control to nodes or participants in the network. So my question here is it necessary to give up on decentralization to reach the outcomes you're trying to achieve? Or are there something that we didn't see today that actually can help to leverage a decentralized system without giving up the throughput and the time to completion of the transactions?
Sure. Very, very good questions. So let's look at the first one. How are validators assigned? You have two options. The first one is you have a regular subnet. So you pick the validators, you provide the validators. That doesn't mean you necessarily need to run the validators, but it gives you control over the validator set, right? So let's say you are in a regulatory environment where all the validators need to be located in the European Union, right? GDPR, whatever it is. This can be now easily enforced, right? So this might be the case for a lot of institutional subnets, like all this. Let's say now you're building a product for more the general user, right? Who wants to, you don't have these requirements, and you want to have it decentralized. Then we call it an elastic subnet. You open up your validator set to anyone, right? You can, you need to give some staking requirements. Let's say you have a staking token, you can use an existing token, you can use AVAX, you can use your own token. And now you, as if you were launching your own blockchain without Avalanche, you can give staking requirements, and now anyone can validate your subnet. You don't automatically get any validators from the Avalanche network, but you can motivate them, right? So let's say you launch your own subnet, you have a staking token, you have a gas token, and now you're telling the validators that are already out there, 1,300, validate my subnet, and you're getting these rewards, these gas rewards, these transaction fee rewards, as if it was on Ethereum, right? Like in Ethereum, validators stake Ethereum, ETH, and then get as a reward transaction fees. So it's pretty much the same thing. You can do permissioned, but you can also do completely permissionless.
Do subnets compete with each other on rewards or?
Yeah, like any blockchain would compete with each other. Yes, like they're not. There's no. Of course. Like if there were two subnets doing something completely similar, offering similar rewards. Since we have 1,300 validators, there's a lot of room, let's just say, right, for competition. But yes, generally they do compete with each other. Your second question was about...
Giving up the centralization.
Right. Giving up the centralization. It's up to you, right? There might be certain situations, and that's what we believe is, we want to enable complete decentralization, and that is totally possible, right? You can, first of all, not use these features like limiting who can transact on your subnet. You don't want to use this feature limit who can deploy a contract. That's totally fine. But why do we offer these features, right? We think that we are not there yet. Not the entire business is going to move on chain tomorrow. But we believe, we call it on-fi, not DeFi. we believe if we move a lot of things, let's say, like a centralized exchange, if that moved on chain, even though it might be permissioned, even though they might have control, it may already be transparent, right? It may already limit to what extent they can do. It's not completely arbitrary, like Web 2 application, they have complete control over all accounts, you don't even know your public key. We already moved to a situation where we are on chain, where there are some permissions. Maybe you have to go through KYC as you would if you sign up for a massive centralized exchange, but it's already on chain, right? So we think it's kind of like a gradual step, and from there you can achieve more decentralization than in traditional. If you look at most blockchain applications or crypto applications out there, centralized exchange, they don't have anything. They're not utilizing blockchain, right? So we think this might be a good first step in the direction.
Thank you. One last question. Is the consensus protocol generalized for every subnet, or every subnet can choose their own consensus?
It is generalized for each subnet. We think it's pretty much maxed out what you can get out of a consensus protocol with a sub-second finality, and if you customize the virtual machine with a high number of throughputs we just saw, in the very distant future there might be different consensus protocols to choose from, but for now, yeah, that's pretty much fixed.
Thank you.
Yeah. Any other questions? I see another. Do you mind handing over the mic?
Yeah, thank you for your presentation. I would like to ask, what is the downside of having multiple chains? Like, you described the increased throughput, but like, what happens in a matter of consistency if you have dependencies between transactions in different? Can that happen? And apologize for my ignorance. I don't know a lot about the Avalanche network,
yeah.
But like, could you describe the caveats there?
Yeah, you hit the nail on the head. What is the cost? Nothing is free in the world, right? So we get customizability, we get scalability, but what is the price for that? And so what you have to figure out is how do you make these chains interoperable, right? We're on different highways now, so you're not on one highway now. So first of all, what we recommend is protocols you're very, very closely knit to, you want to put them on one chain, right? Let's say, like a few DeFi applications. They can be on one chain, they have like a lot of interoperability, but like if you're an institutional finance protocol, you probably don't have anything to do with this NFT gaming marketplace, right? There's no need for them to be on chain. So first of all, bring them together, but then we need to figure out interoperability between chains, and that's what we're actually doing. It's called Avalanche Swap Messaging. If you're familiar with Cosmos IBC, it's somewhat the same idea, so cross-subnet communication. And this is actually a challenge all chains have. So if you look at major DeFi protocols that are now cross-chain, they have pools on Polygon, they have pools on Ethereum, they have pools on Avalanche. They all need to interoperate. And what we're actually seeing, since we have that shared layer, interoperability between subnets is actually easier than creating interoperability between Avalanche and Ethereum itself, right? So actually the interoperability between the chains is, compared to the interoperability challenges in the overall blockchain space, pretty manageable, but it's still introduced. You don't have what we call atomic transactions anymore, so you have to do the hops from one blockchain to another. Very good question. All right, any other questions? Otherwise, I think we can move to the next. I'm not sure if I'm stealing your time already. Okay. Oh, one more. There's one more question here, I think.
Thanks for your talk. I have a question regarding the validators and in the subnet. So I was wondering if there might be an issue with the throughput if you get, let's say, like congestion on the validator. So let's say there is this a certain amount of validators, and maybe there will be a lot of subnets, and so each validator has to validate a lot of subnets. Is this a problem that might arise, or?
It's very, very good point. So it really depends on the chain. If you had two completely overlapping validator sets, so they're identical, right? Then actually you wouldn't need two subnets, you could just put them all in one subnet. But in general, yes. And what we see in practice, I would say one validator, depending on the hardware requirements, but like with reasonable hardware requirements, not like ultra computers or something, can validate, let's say, 4 to 5 subnets, depending on the throughput of each subnet and everything. But yes, but as long as the validator sets are completely distinct, or let's say at least they don't have an overlap of more than 20, 30, 40% of the validators, completely independent. It doesn't really matter. Yeah. Okay. But if there's some high overlap, there's a chance.
Okay, thanks.
Cool. Awesome. Thank you very much. As I said, we're going to be here today, tomorrow. Feel free to find me if you have any other questions or like to talk about building on Avalanche. Thank you very much for your attention. And now my colleague from Everscan is going to come and do a quick workshop.